First, to set the stage, I want to dive deeper into the scope of OpenLABEL, specifically what's in scope and what's also not in scope of OpenLABEL. So Nico was giving a great example on how OpenLABEL come together with the other standards of the OpenX family. And this example was specifically geared towards simulation. Which is great because despite the fact that specifically for multi-sensor data labeling, OpenLABEL is really has been designed and conceived for the real-world sensor data. But one of the driving principles that we used was to design something with having in mind the goal to bridge the gap between real-world and simulation data, so that we also design a lot of features in the standard in a way that it is possible to, basically seamlessly transitions from a real-world representation from sensor data to a digital twin, let's call it, or a simulated representation of a similar scene. And that's also what Nico was explaining. And in terms of what is in the scope for our standard, there are two main buckets, as I mentioned in the introduction. So one is related to multi-sensor data labeling, where we define and organize the annotation data structure, including the geometries, the coordinate systems, the transforms across different sensors, and any other concept that is fundamental and relevant for the spatiotemporal annotation, let's say. What we do not provide in this use case is a specific taxonomy or ontology of physical or abstract entities. So we're not providing you a list of car, vehicle, truck, pedestrian, etc., etc. But of course, that's a central piece of labeling, right? So what we do here instead is to specify mechanisms to basically include external ontologies or knowledge repositories where this semantics of the label is well organized and well defined, that can be pointed to from the specific annotation instance in OpenLABEL, so that then basically we detach the semantics from the pure data model for labeling all of the information, so that then the semantics become much more manageable and extensible, modifiable in the future without the need to retouch a lot of the fundamental things in the labeling data per se, label data per se. So, of course, we do that with a high preference for OpenX ontology, which is the standard that Nico you mentioned and introduced, since that's giving the whole, let's say, semantics of the overall domain model of road traffic, which is used across all the other ASAM standards. OpenX standard. And also for this version, we do not provide rules, specification, or guideline on how to annotate entities for multi-sensor data labeling. So we don't give a guide on, for example, for cars, don't label side mirrors or all of these things. We really focus on the data model here in the format. On the other hand, for scenario tagging, the scope is very similar. We still define and organize the annotation data structure for test scenario tagging. But for this specific use case, we also define the taxonomy or ontology of specific standardized tags, semantic tags that need to be used in order to be compliant with the standard. And why is that so? Because in order for the scenario use case to be actionable and of value from day zero, we needed this standardized set of tags. And of course, with time, these will converge with OpenX ontology as well. And you will hear from Jason and Mike, who led this package about how we went into standardizing these tags. And again, another highlight is scenario tagging is not defining a language or format to describe test scenarios. That's not what we do. That's more open scenario type of thing. Here we just enrich with metadata those scenarios. And this naturally leads me to the, let's say, conceptual overview of how OpenLABEL is designed at a high level. So we decompose the task of a data annotation as the general process of enriching, let's say, raw data, such as LiDAR streams or camera streams, radar, etc., or even test scenarios or whatever type of data you want to think of. with, let's say, additional metadata, which is related to the semantic content of the raw data, for example, like which are the static objects or dynamic objects populating a video, or the actions they are performing, or some environmental conditions, but also with additional information, like, for example, the calibration matrices or administrative type of information, like author, version, etc. So basically, the whole idea is that we have an annotation instance that enriches with annotation this raw data. And within this annotation instance, we refer to, we outsource, let's say, the semantics of the entities that we want to label to external knowledge repositories like taxonomies or ontologies like ASAM OpenLABEL ontology. The bulk of the standard is the fact that this annotation instance should conform to a shape, like a schema, to be valid. And that's really what OpenLABEL is an annotation schema that defines the structure of the data model to annotate some raw data. And for scenario tagging, the scope includes also the specific knowledge repository that is informed. It's like used in order to do this exercise. So in terms of deliverables for this standard, we have for multi-sensor data labeling, we have, of course, the documentation, the JSON schema available as a file that can be used to validate against valid instances of OpenLABEL annotations. And of course, a bunch of examples to showcase how to use the various data types and annotations in a valid way. And for scenario tagging, we have the exact same elements, but of course, as I mentioned, we also introduce the standardized set of tags and their hierarchy in RDF turtle syntax that basically relates to the scenery, environmental condition, a bunch of other dimensions for tagging scenarios. So just a high-level introduction of the JSON schema structure, but then we'll have Marcos Nieto from Decompec. I was the project leader for this work package, and he's going to be really diving deeper into the various pieces. But just as a general overview, in terms of JSON schema structure, we have some very high-level semantic categorization of what we're going to label, expressed in terms of actions, objects, events, context, relations, mainly, and of course, divided per frames. We have the tags for scenario tagging, and we have some what we call metadata, which are pointers to external ontologies, to other resources, because again, mentioning the use case that Nico was presenting before, we can, for example, if we are in the need to label lane markings in a real-world sensor recording, what we could say using this resource element is this specific polyline that I labeled in my camera view is exactly the same lane marking that I have in my, let's say, OpenDrive file, which is describing the same network structure of the real world. And then we have streams and coordinate systems. Finally, before handing it over, I will just reference the other standards that we are basically citing or that are linked to OpenLABEL, namely the JSON schema specification, the turtle syntax, BSI PAS1883 for ODD tags, the SA J316, the various ASAM OpenX family standards, and also I want to highlight that the ISO 34504 is also dealing with tagging of scenarios, and that's also standard where we have a lot of alignment with. We made sure to have a lot of evaluation, alignment meetings and interactions, so to make sure that we are really doing similar things and not diverging too much. I think that was it. Nico is still on me now to introduce